Let's see together how SQL Data Insights works. All the components of SQL Data Insights run on ZOS. Once you installed, you can connect to your target Db2 subsystem from the browser. I'm using existing data connections, Db2 connections called Db2 perf using my Db2 user ID. Once connected to Db2, we can list existing AI objects. Currently, there are 4 AI objects that are enabled. To enable AI against my chan table, I can go Add Objects and click Schema. Look for my table, chan table 2. I just click Enable AI Query, which brings to a few setup before triggering the training. First, select the columns to be included in the models. I'm going to include all the columns. Each column can be defined with different attribute. I'm setting customer ID column as a key columns. Optionally, we can filter out values we want to exclude from the training. Once we are done, then enable. This is all you need to do for starting the training. As you can see, it will be helpful to know your data and tables, but there is no need of data science skills to start creating the models. Training for this table is running and will take a couple minutes. So meanwhile, we will take a look at how to run the queries using the already trained chan table. It is here. So it is like a cooking show. Query can be executed from any places where you can connect to the Db2. However, this UI also provides a quick interface where you can run SQL. We also provide the sample queries using a chan table, an AI analogy, AI similarity, semantic cluster, so on. In this use case, we have a customer 8779 who had left the business, so we want to prevent likes of this customer. The new built-in function, AI similarity, uses this customer as an input and finds the records that are similar to 8779. The information of this customer and the relationship with other entities are pre-computed through deep learning algorithm as a vector and stored in a model table. Key point is that we are looking at the relationship between the rows and columns, unlike traditional SQL that is value-based. Now sorting descending order from the higher ranking, we get the most similar rows from the customer 8779. The first row is an input row we used, and you can see the subsequent records have similar value in a column such as row value in a tenure, or no phone services, or internet service as a DSL, or contract, or monthly charges around 40 to 45, so on. Now once we have the sets of the customers who are similar to the one who had already left, and then we can use a more comprehensive information with a set of the customers based on a group using a semantic cluster functions. Here is the samples. I'm using those top two customers as well as 8779 and run the queries. Here is the results. Now you get the more comprehensive information. Tenure is still the row on phone services and DSL, so on. Additionally, I want to look for the sets of customers who are very different from this customer 8779, basically a model customer, and their characteristics so that I can use the information for promotion possibly. It is quite easy to do that in SQL. Going back to the original query, make those things listen, and then make this ranking as ascending order. Now we are getting the row that is very different from the 8779. Executing the query. As you can see, yes, tenure is a lot larger. Phone services, yes. And internet service, fiber optics, as opposed to DSL, so on, monthly charges a lot bigger. So now the training that I submitted previously should be done, which is true. Now I can look at the models. There is some explanation for what type of the clustering we created. Also, we have capability to analyze the data. Those are some object detail. This table has very small 7,000 row, and data statistics is similar to Randstats, and the column influence scores, and also discriminating score. Discriminator score indicates the most differentiating columns when we rank the rows. In this case, tenure has the highest score. This is a very simplified version of the use case, but hopefully this short video gave you an idea of our very new way of exploring data using embedded deep learning technology against the data that is securely stored in a Db2 for GOS.